Welcome to my channel, everybody. There is an important integral to solve this problem, and we'll be happy to show this solution. Okay, let me tell you a story before making this solution. And now, what is the story? In a few years ago, a student came to my home to take admission, and I take admission that student, and after a few days, some year ago, give us some problem, and this problem actually, see what is the power, that is 5, and ask me, sir, you can do it. So after a few time, I take a time, small times, this like a new problem to me, in like 7 to 8 years ago actually. Okay, then I do it. Actually, question is that some teacher they want to pressure me to sending this unknown type of problem to given me, and he think about that as teacher will be failure to solve this question, and taking this solution, and that students asked to that student, say, we can do it, sir, but the teacher was failed, and then saw my solution. Okay, then saw my solution to that teacher. Okay, after that, that student continued to my coaching, and to the master degree, up to the master's degree. Okay, so this is the history. And few months ago, like a 6 and 4 months ago, and same type of problem came on FB, and I solved it. But this is not worth that after the some teacher give my FB and ask me questions, sir, you can do it, sir. So it is done by me. So I am easily sending my solution. Okay, so this is the history. Okay, about this problem. Okay, see how can do it. It is a very interesting question to me. And actually, this is the factorization do the factor. How can to factorize this problem? And see the procedure. Here is sine to the power 5x, and this is here cos to the power 5x here. Okay, I take a common here, cos to the power 5 to the power x, and this is here tan to the power 5x plus 1. Okay, let a is equal to tan x here. So this is here cos to the power 5x and a to the power 5 plus 1. Now we have to factorize this. Actually, see, this is the odd part. If we take when a plus 1 equal to 0, actually this is a factor. If we put this expression, then it is a 0. So this is the zeros is a equal to minus 1. So this is a one factor, and what will be the other factor? Actually, this type of factorization, and if we take this as a 0, then this call as a multiplier. Okay, and see the technique to easy to solve, easy to factor. How can do factorize this? As the power be here 5, so coefficient of a to the power 5 be here 1. But see, a to the power 4, a to the power 3, a to the power 2, a are absent there. Actually, there is no absence. We can assume a 0 into a to the power 4 plus 0 into a to the power 3 like that. Okay, so the highest power be 5 here. So other, like a to the power 4, the coefficient is 0 here. A to the power 3, the coefficient is 0 here. A to the power square, coefficient is 0 here. A, the coefficient is 0 here. And after that, the constant is here 1. Okay, this is the technique. After that, the right here 1, and if we multiply this, then we get here minus 1. Okay, if we added this 2, then we get here minus 1. After that, this into this, we get here 1. And then added these two, we get here 1. After that, this into this here minus 1. Okay. Okay, then we get here minus 1. After that, this then also we get here minus plus 1. Sorry, and if we multiply this, we get here minus 1. So if this is a factor, so we show here as a 0. So actually this is proved. It is a factor in, and if we put this value, actually need to get a 0, then it is exactly shows that this is the factor. So then what will be the other factor? And this is the coefficient of the other factor. Okay. So therefore we can write here a to the power 5 plus a to the 5 plus 1, and this is equal to a plus 1. Okay. And now this is we have other factor. We have as this is the power degree is 1 here, and this is the 5. So the highest power of the a be 4. So okay. So a into 1 into a to the power 4 here. Then after a to the power 3. Then after a to the power 2. Then after a. Then after plus 1. Okay, now if it is at 10. So 10 to the power 5x plus 1. So this is equal to 10x plus 1. So this is 10 to the power 4. 10 to the power 4 x, 10 cube x, 10 square x, minus 10x, and plus 1. Okay, and see, this is the multiplication of cos to the power 5. So cos to the power 5x into 10 to the power 5x plus 1, and that is equal to sin x plus cos x, and take a LCM like sin to the power 4 by cos to the power 4. So what happens, see here, this is here sin to the power 4. Okay, if we take LCM, therefore this is here cos to the power 4. If we take here LCM cos q and take a LCM sin to the power 4, cos to the power 4. So here we get here sin to the power 3x into cos x. Okay, after that this is a square, so we get here sin square x and into cos square x, and then we get here sin x into cos to the power, actually this is a 3x. Okay, so this is the factor of that. So now we can easily solve this. And this is a lengthy problem, and see the technique here. And now put here as a factor, this is sin x plus and cos x, and also the other factor here sin to the power 4x, and this is here cos to the power 4x first. Then after we get here sin cube to the power x into cos x. Then after sin square x into cos square x. Then after minus sin x, and here is cos qx. Okay, students, see carefully. This is the most very interesting question about me. So see, sin x plus cos x. Okay, multiply by numerator and denominator both. Then this is here sin x plus, and this is cos x whole square. Now a square plus b square. So a plus b whole square minus twice ab. A plus b whole square, that is 1. As this is a sin square whole square, cos square whole square. So this is, we can write here 1 minus 2 sin square x and cos square x. Okay. After that we can write here, this is sin square x and cos square x. If we take a common, that is sin x and cos x, then the other factor will be here sin square x plus cos square x, and that is equal to 1. Okay, that is equal to 1. Now see, this is here sin x plus cos x dx. If we expand this, we get here 1 plus 2 sin x and cos x. And now we do the simplification. If we add this, then we get here sin square x and cos square x. Okay, so this is here minus sin x and this is here cos x. Okay, so now let y is equal to sin x minus cos x. So if we derivative, then we got cos x plus sin x into dx. Actually these are tally. Okay, so we got in place of that we can put dy. Now if we squaring both sides, then y square is equal to, this is a sin square plus cos square is 1 and minus 2 sin x and cos x. So implies that sin x and cos x is equal to 1 minus y square by 2. Okay, so apply these 2 points on the integral. Okay, so this is here dy. So now 1 plus, this is 2 sin x cos x is equal to 1 minus y square. After that, and this is a square, so that's why 1 minus y square by 2 and the whole square. Okay, after that this is here 1 minus y square by 2. Okay, so see, this is here dy by 2 minus y square, and take a simplification. LCM is 4 here. So this is 4. We write here 1 square means 1 here, and this is plus y to the power, so that is y to the power 4. Minus twice the minus plus 2y square, y to the power 4 here, sorry, this is y square. And this is here LCM before, so multiply by 2. This is 2 plus 2y square. And now this is there 4. So take a common minus. We write here y square minus 2, and also take a common minus here from that. Okay, so we get here y to the power 4. Then this is as a 4, so as sign change we take a common minus, so minus 4y square. This is a 4 minus 1 minus 2, this is we get here minus plus 1, so as we take a common minus, so this is there minus 1. Okay, now factorize this. Okay, and what is the factor of that? So see here y to the power 4 minus this is 4y square and minus 1. So see y square 2 y square dot 2 plus 2 square, so you get here whole square, so this is minus 5. Okay, so y minus 2 whole square, and this is root 5 whole square. Okay, and now see, this is the doing start, and see the calculation here. Okay, so y square minus 2 plus root 5 and y square minus 2 minus root 5, and let a square is equal to 2 plus root 5 and b square is equal to, actually this is here root 5 minus 2. So this is the root 5 minus 2, so a square plus b square, and write here y square minus a square. So see carefully what is the value of a square b square. Now put this factor in place of that. Okay, so then what happened, see, so this is here dy, So this is here y square minus 2, and after that y square plus b square, and then here is y square minus a square. Okay. See, we want to partial fraction. Need to want to a partial fraction. And about me, this is easy. So see how can factorize partial fraction to do here. See here, y square minus 2. So this is here y square plus b square, and this is here y square minus a square, and that is equal to y square minus 2. We can write here like that, 1 by y square minus a minus y square plus b square. If we take a LCM, then we got on the numerator part we have b square plus a square. So here is absent b square plus a square, and that is a constant. So we can write here 1 by, this is a square plus b square. Okay, a square plus b square. So see, if we added these a square plus b square, got 2 root 5. Okay, so now we have put here 2 root 5, and left here is y square minus 2, and also and this factor we multiply with that, then y square minus 2, and see here y square minus a square, and again, and this is here y square minus 2, and this is here y square plus b square. Okay, and now 1 by 2 root 5. Again, factorize partially. So this is here y square minus 2. So we do have y square, okay, and minus y square minus 2 actually. Okay, and see what happened here. See here, if we take a LCM, then minus 2 plus a square. Okay, so this is here, this is here plus a square minus 2. So what is the value of a square minus 2? This is root 5. So we can write here 1 by root 5, and minus 1 by 2 root 5. Same as we can write here, if we take a LCM, y square minus 2 minus 1 by y square plus b square, minus 1 by 2 root 5. We want to do like factor. This is our y square minus 2 minus 1 by b square plus y square. It would be a, if we take a LCM, then you get a b square plus 2. Actually, this is a b square plus 2 as a root 5 also. So, as a root 5 also, this is 1 by, so root 5, okay. This is a b square plus 2. So, you can balance here, b square plus 2 is here 1 by root 5. Okay, so actually the two common are same. So, we can take a common 5 to the 10 here. So, this is here 1 by y square minus a square. This is here 1 by y square minus 2, minus minus minus, actually this is y square minus 2 also, and this is here plus y square plus b square. Okay, I want to check the calculation. So see, if you take a LCM of that, and then we get there a square minus 2. What is the value of a square minus 2 is root 5. So that's why 1 by root 5. So again, this is here b square plus 2. So this is here b square plus 2 is root 5 also. So that's why 1 by root 5. Okay. So 5 root 5 is root 5 is 5. 5 to the 10. We take a common 10 on the both of them. In the middle there is a minus. So minus both the same. Okay. Right. Okay. So see, the solution here is 4 by, actually LCM we have 10, 1 by 10 there. Okay, now here is that 1 by y square minus a square, and both the middle are same. So that's why 2 by y square minus 2, then after plus 1 by, this is here y square plus actually b square. Okay. So this is now dy. This is now dy. So this is 2 by 5 here, and separate this the integral. Actually, you can write here exactly apply the formula here. So for that formula is here 2a and ln y minus a by y plus a here. Okay, and for that this is 2 by 2 root 2, and these also are ln y minus root 2 by here y plus root 2. Okay, after that this is here 1 by b tan inverse y by b here. Okay, so plus c. Now multiply by this is here 2 to 0 are cancelled, so 1 by 5a. So this is there 5a. What is the value of a there? A means root over, this is here a, root over 2 plus root 5, and ln mod of, what is the y? Say sin x minus cos x. Okay, sin x minus cos x, and minus a. A means here this is root over 2 plus root 5. Okay, same as sin x minus cos x. This is here root over 2 plus root 5. Okay, and multiply this by this. This is 2 are cancelled. So this is here 2 by 5 root 2, and right here ln, and same, this is here sin x minus cos x, and this is here minus root 2, and also you can write here sin x plus cos x plus root 2. Okay, then multiply by 2 by 5 with b, and this is 2 by 5 5b, and b here is root over root 5 minus 2 actually, and this is here into tan inverse. This is tan inverse y. Y means sin x minus cos x. Okay, by b. By root b means this is root over 5, root over root 5 minus 2 there. Okay, so this is the with plus c. This is the solution of this problem, and very interesting question. See carefully. Okay, and here is the main technique of that. There is the factorization, and how can apply the y here is, see carefully. Very interesting question, all of you. Okay, I think all of you will be happy to see this video. Okay, see carefully. And next I want to introduce for who want to appear the joint and IIT advance, and that's why you have to introduce some differentiation and integral with the limit. Okay, with the limit. Okay, see carefully and follow my video. Okay, bye everybody.